Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is edit distance. It's a hard level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. So given two strings word1 and word2, we have to return the minimum number of operations required to convert word1 to word2. And the operations permitted are: we can insert a character, delete a character, and replace a character. So let's see an example to better understand the question. So we are given with word 1 as horse and word 2 as Ross. So in how many operations we can convert horse to Ross is: first we will replace H with R. So the first character will H is converted to R, and then we will remove R. So the middle element R is removed. So the rest of the characters are Ross, Rose, and then we'll finally remove E. So once we remove the end character, Rose becomes Ross. So in three operations, we finally managed to convert horse to Ross. So let's see how we can solve this problem and which algorithm we will be using. So we will use dynamic programming uh, and basically tabulation approach. That is what also we call as bottom up approach. So as we know, in tabulation or bottom up approach, we first find the solution for the smallest sub problem, right? We define the smallest sub problem and also called the base case or base condition, and iteratively we compute the result for the larger sub problem using this result of the smaller sub problems. So I've taken one example where word 1 is ABC and word 2 is AQC. So we can define our base condition, or the smallest sub problem is: if word 1 is empty, then the edit distance or the number of operations will be equal to the length of word 2, right? So if the word 1 is empty, so whatever uh, is the length of word 2, those many operations are needed to convert word 1 to word 2. Similarly, if word 2 is empty, then the number of operations or the edit distance will be equal to the length of word 1. Also, we will define a 2D array, that is what we called a DP array, of size word 1 length and word 2 length, right? So DP will store the solution for the sub problems, right? So that is what we call the edit distance for every sub problem. So if we say DP of So if we say DP of word 1 index and word 2 index, it means that it represents the edit distance for word 1 ending at index word 1 index, and for word 2 ending at index word 2 index. We will start from our the smallest sub problem or the base condition. So what is the base condition? If word 1 is empty, the edit distance will be equal to the length of the word 2. So as we can see, for the first row, word 1 is empty, so the edit distance will be the length of the word 2. So the length of the word 2 is 0, 1, 2 and 3. Similarly, for the first column, word 2 is empty, so the edit distance will be the length of the word 1. So for the length of the word 1 is 2, 1, 2 and 3. Now the character for word 1 ending at index 1 is A, and the character for word 2 ending at index 1 is A. So the characters match. So if the characters match at index word index 1 and word index 2, so the DP of word index 1 and word index 2 will be equal to DP of word index 1 minus 1 and word index 2 minus 1, right? So it will be the D d minus 1, and it will be the diagonal up element. So it will be same as this diagonal element, that is 0. Right, now for this cell, the uh, the index for word 1 is a, and for word 2 the index is 2, that is the character q. So we have to match a and q. So a and q does not match. Now when the characters do not match, so when characters not match, then we have to take minimum of 3 operations, that is insert, delete and replace. So when we insert, right, so if we insert for the a and aq, so the current word 1 is a and word 2 is aq, right. So when we insert the last character of word 2, right, into the word 1, so the last character of word 1 now will become equal to word 2, and the remaining word 1 will become a, and now word 2 will become also a. Right, so the edit distance, for word 1 a and word 2 aq will be equal to the edit distance of word 1 a and word 2 a plus 1. Plus 1 because we are inserting the last character of word 2, that is q, as a last character of word 1, and this operation counts as one operation, right. And after the insertion, we are moving towards the left to match the rest of the characters or the rest of the word for word 1 and word 2 respectively. So this insertion that we are doing for the letter q, right, so this counts as one operation. That's why we are doing plus 1. So for dp of word index 1 and word index 2 will be equal to dp of word index 1 and word index 2 minus 1 plus 1. So for this cell, that is dp of 1 comma 2, it will be dp of 1 2 minus 1, that is 1 plus 1. So dp of 1 is 1 comma 1 is this one, so we will add, so it will be 0 plus 1, that is 1, right. So for insert, the dp of this cell will be 1. Now we will see the other two operations. So for delete, right, so for delete, we the word 1, again word 1 is a and word 2 is aq for this cell, right. If we delete a from the word 1, so the now word 1 will become empty and word 2 will become aq. So the dp of word index 1, right, word index 2 will be equal to dp of word index 1 minus 1 and word index 2 plus 1. So here plus 1, again we are doing plus 1, similar to the insertion operation where we did plus 1, right, because we had already did one insertion operation and then we were moving left, right, for the rest of the word for word 1 and word 2. Similarly, we have performed one delete operation here, right. We have deleted a from the word 1 and then we are moving towards left for the rest of the word 1 and word 2. So we have already performed one operation, that is why we are adding plus 1, and then we are doing dp of word index minus 1 and word index 2. So for this cell, dp of 1 comma 2 equal to dp of word index 1. So word index is 1, so 1 minus 1 is 0. And for word index 2, so word index 2 is 2, so it will remain as 2 plus 1. So 0 comma 2, so 0 comma 2 is 2, right? So it will be 2 plus 1, that is 3, right? Now the last operation that we have to see is replace. So for replace, again the word 1 is a and word 2 is aq. So if we replace the word 1a with q, right, so now as the last characters now become equal, right, and when we move to the next character, the word 1 will be become empty, right, and the word 2 has only a character will left, because we have matched the q, the last character, because we replaced a with q, the q matches with the last character of word 2. So we will move next, we will move to the next element. So for the next character for word 1 is empty, and for the next character for word 2 is a, right? So now, so for dp of word index 1 and word index 2, it will be equal to 1 plus dp of word index 1 minus 1 and word index 2 minus 1, right? So for dp 1 comma 2, it will be dp of 0 comma 1 plus 1, right? So it will be dp of 0 comma 1 is 1, right? The diagonal element 0 comma 1 is 1 and plus 1 will be 2, so 1 plus 1 equal to 2. Now whenever the characters do not match, we have to take the minimum of all the three operations, that is insert, that will be 1, delete, that is 3, and replace, that is 2. So minimum is 1. So here when the characters do not match, like a does not match with q, so for insert we do 0 plus 1, 0 plus 1, that is 1. For the delete we do 2 plus 1, that the cell above, the 2 plus 1 is 3. And for the replace we take the diagonal value 1 plus 1, 1, that is 2. So the minimum is 1, minimum is 1. Now for this cell, right, the word 1 index is 1 and the character is a, and for the word 2 the index is 3 and the character is c. So as a and c do not match, right, then we have to take the minimum of all these three operations, that is insert, delete, and replace. So the minimum will be 1 plus 1, that is 2. Now for this cell, the index for word 1 is 2, that means the character b, and the index for word 2 is a, that is index 1, that is a. So a and b do not match, then again we have to take the minimum of all the three operations, so it will be 0 plus 1, that is 1. Now for this cell, the index, again the b we have to match with q, so they do not match, then we have to take the minimum of all the three operations, that it will be 0 plus 1, that is 1. For this cell, again the characters do not match at the index 2 and 3 for the word 1 and word 2 respectively, so we have to take the minimum, that is 2. For this cell, again we have to compare c with a, so they do not match, we have to take the minimum, that is 2. Now for abc and aq, c and q do not match, then we have to take the minimum, that is 2. For abc, aqc, c and c match, the index, the character at index 3 for word 1 and the character at index 3 for word 2, that is c. So c and c match, then when the characters match, we take this value that is diagonally up and place at the at the current cell. So this is the value, that is we need one operation to convert ABC to AQC, right? We can confirm this. So ABC to convert AQC, we can directly take Q and replace B to Q. So it take only one operation. So let's see the code part for it. So I have coded the solution in the Java code. We have given a class solution and a method that is min distance. It takes two input, word1 and word2. Calculated the word1 length and word2 length for both the words. If word1 length equal to 0, we will return word2 length, right? Because if word1 is 0, it means word2 length is the minimum number of operations we have to do to convert word1 to word2. Similarly, if word2 length is equal to 0, we'll return word1 length. We'll initialize a DP array, right, which will represent the edit distance for word1 and word2. So first we'll fill our base conditions or the smallest sub problems. As we did in this for loop, we filled the first row and the first column, right? So this is what we are doing here. If for starting from 1, one index equal to 1, if it is less than equal to word1 dot length, and then we will set dp word1 index 0 to word1 index, right? And similarly for word2 index equal to 1 and word2 index less than equal to word2 length, we'll set dp 0 word2 index equal to word2 index, and we'll iterate over each cell, right? Or we'll iterate over each combination of the two words as represented by this matrix. On the left side we have empty AB and ABC. Similarly for word 2. Now we will check two conditions: if the characters match or if the characters do not match. If the character for word 2 at index word2 index -1 matches with the character for word 1 at index word1 index -1, then we will copy the dp of word1 index -1 and word2 index -1 to dp of word1 index and word2 index, i.e. the number of operations for the word ending at index word1 index and word2 index will be same as the number of operations or edit distance equal to the word ending with word1 index -1 and word2 index -1. Else if the characters do not match, right, then we will take the minimum of dp for insert, delete and replace, and we will do +1 after calculating after taking the minimum, and we'll paste and we'll copy the value into the dp of word1 index and word2 index, the current cell. And once we iterate over all the combination of the word1 and word2, we'll return the dp of word1 length and word2 length, i.e. this value in the last cell. So let's run this solution. So yeah, test cases are accepted, so it means the solution is working fine. Let's see the time complexity and space complexity for this algorithm. For the time complexity, as we have running two for loops, one for loop running till the, in the worst case, running till the length of the word 1, and the another for loop running worst case till the length of the word 2. So time complexity will be big O of n cross m, where n is the length of word 1 and m is the length of word 2. And the space complexity will be again order of n into m, n cross m, because we are maintaining a DP, right, with the size word length plus 1 and word 2 length plus 1. So in the worst case, it will be big O of n cross m. So I hope you enjoyed watching this video. If you like this video, please share and subscribe. Thanks for watching. It will give me motivation to keep on going like this and present to you with more such algorithm and data structure concepts. Thank you.